Hello student, good morning. I am Dr.A.J. Kumar Sinha, Professor of Chemistry. Today I am going to discuss oxides of nitrogen. Last class I have discussed preparation, properties, uses of nitrogen and ammonia. Now I am going to discuss oxides of nitrogen. There are different type of nitrogen. Nitrogen forms a number of oxides in different oxidation states. Then what are their names, formula, preparation and physical properties? That I am telling you. What are the names of oxides of nitrogen? What are the formula? What is their oxidation state and how it is prepared? I will tell you. Okay, and also I will tell you physical properties, physical and chemical properties, main physical and chemical properties I will tell you. Then first oxide is dinitrogen oxide. Dinitrogen oxide, that is the N2O. Its formula is N2O and oxidation state of nitrogen is +1. And what is actually common method of preparation, how it is prepared? N2O, how it is prepared? First oxide, dinitrogen oxide, N2O. Then it is prepared by ammonium nitrate on heating. If you will heat ammonium nitrate, then you will get N2O and water. Means balanced equation you can write NH4NO3. It gives two product N2O plus 2H2O. Okay, after heating ammonium nitrate. Now what is its physical properties? It is the colorless gas, no color, and it is a neutral gas, no acidic, no basic properties, neutral. Okay, and colorless gas. Now second oxide, actually dinitrogen oxide is also called nitrogen 1 oxide because oxidation state is +1. Okay, that's why it is called nitrogen 1 oxide. Now second oxide I am telling you nitrogen monoxide, NO. It is also called nitrogen second oxide because its oxidation state is +2. And how it is prepared? Then it is prepared by sodium nitrate, ferrous sulfate and H2SO4. Three things is required to get the NO gas, NO, nitric oxide. Then what are that three things? Then NaNO2 plus FeSO4 plus H2SO4. Three things is required. Then you will get Fe2SO4 whole 3 plus 2NaHSO4 plus 2H2O plus 2NO, means 4 products you will get. 3 reactants are required and after the reaction it will give 4 products. And first product is ferrous sulfate Fe3SO4 whole 3. Okay, ferric sulfate. See, it is a cross Fe2SO4 whole 3 and 3 is for Fe. That's why it is called ferric sulfate. Then first product is ferric sulfate, second is sodium hydrogen sulfate, also called bisulfate. Sodium hydrogen sulfate. Third product is water, means H2O, and fourth product is NO, nitric oxide. This reaction is very, very important and is asked in many examinations. Okay, again I am telling you, 3 reagents are required. First is NaNO3, second is ApSO4, third is H2SO4. Okay, and 4 products it is giving. Already I told you. Balanced equation, how will understand? I am telling you. 2 NaNO3 plus 2 FeSO4 plus 3 H2SO4, and product you will get Fe2SO4 whole 3 plus 2 NaHSO4 plus 2H2O plus 2NO, all are 2 2 except Fe2SO4 whole 3, it is only 1. And what is a properties? Then it is a colorless gas, and it is also neutral, no acidic, no basic, it is neutral. Question is asked here in every oxide, or you can tell every oxides are asked, every oxide is asked in examination, their properties, their reactions, correct? Hence you should understand it. Okay, then I told you 2 oxides. Now third oxides, here oxidation state will be 3. Okay, this is actually according to the oxidation state. Oxides are according to the oxidation state. Then third one I am telling you, that is the N2O3. N2O3. Then N2 you can tell dinitrogen trioxide. N2O3. N2 means dinitrogen, O3 means trioxide. It is also called nitrogen third oxide because oxidation state is +3. Now how will you get N2O3? Then this you will get by 2 reagent, nitric oxide plus N2O4. N2O4. Okay, both are oxides of nitrogen only. Then 2NO plus N2O4. On heating around 250 Kelvin, you will get 2N2O3. Balanced equation, I am telling you, 2NO plus N2O4, dimer of NO2. N2O4 means dimer of NO2. Okay, then 2NO plus N2O4, you will get 2N2O3 if you will heat around 250 Kelvin. And what is its properties? Then it is a blue solid. N2O3 is a solid blue. Question is asked. Okay, all you remember what I am telling you, all are important things only. Then N2O3 is solid, blue solid, and it is acidic character. N2O3 has acidic character. You have seen what I have discussed too, that was neutral. Now it is a third one is means N2O3 is acidic. Now fourth oxidation state, fourth oxides of nitrogen I am telling you, that is the nitrogen dioxide, NO2, nitrogen dioxide. It is also called nitrogen 4 oxides because its oxidation state is +4. Okay, all oxides are due to different oxidation state. I started with +1, +1, +2, +3. Now fourth one I am telling +4. nitrogen dioxide NO2. How will you get? Then this you will get by a strong heating of lead nitrate PbNO3 whole 2, PbNO3 whole 2, lead nitrate, very important reaction. Then lead nitrate, if you will heat it around 672 Kelvin, then you will get 3 products. What are that 3 products? Then first you will get NO2. First product is NO2. Second product is lead oxide. Third product is oxygen. Okay, all 3 products are useful. Then balanced equation, you can understand 2BNO3 whole 2 means lead nitrate, 2PbNO3 whole 2. It gives 3 product, 4NO2 plus 2PbO plus O2. Okay. Now I am telling about the properties. All are in shortcut. Then it is a brown gas. NO2 is a gas. Its color is brown. Question is asked. And it has acidic character. Okay. Now this plus 3 and plus 4 both are acidic character, and plus 1 and plus 2 was neutral, or you can tell plus 1 and plus 2 oxide were neutral. Now next fifth one I am telling you. Fifth one is a dimer of NO2. Oxidation state is same, but it is a dimer of NO2, means N2O4. It is also called nitrogen 4 oxides. It is a dimer. Why it is making? Question is asked. Why NO2 is making a dimer? Question is asked. Then now I am telling explanation. Here nitrogen, in NO2 nitrogen has nitrogen, you know, that is a 5 valency. The last orbit there it has 5 electrons, but oxygen given only 4 electron, O2, each oxygen 2. Then in NO2 molecule 1 electron is extra. Out of 5 only 4 they got. Correct? 2 oxygen means 4 electron, and nitrogen has 5 valency. Then 1 electron is there. In NO2 1 electron is there. Hence it will dimerize, because in making a bond 2 electrons is required. That's why it dimerizes. Hence NO2 gives 2 molecules of NO2. It gives N2O4. Oxidation state is same, plus 4. And how will you get it, N2O4? Then you will get it very easily from the NO2. 2 NO2 you will take, you will get N2O4. And here you have to, here I am telling important things. When you will cool it, NO2 is there, 2 NO2 is giving N2O4. How we will get? Then by cooling. By cooling, what will happen? Gas molecules will come close by cooling. Correct? Gaseous molecules means NO2 will come close, and it will dimerize, and it will give N2O4. And from N2O4 you can get NO2. How? Then if you will heat it, then you will get NO2. Means it is a reversible reaction. Reversible. 2 NO2 after cooling you will get N2O4, and N2O4 after heating you will get 2 NO2. And this is a colorless gas. N2O4 is colorless, not gas, colorless solid. It is a colorless solid. Okay. Then now only got till time this you got 2 solid. Okay. Till now you got, I told about only 2 solid. out of 5, 2 solid. First solid was this thing, N2O3. N2O3 was solid, blue solid, and this fifth one, that is the colorless solid, or it may be liquid also. It can be liquid also, solid also, but its character is acidic character. Then now 5 I have discussed. In that 2 are +4 only oxidation state, and 3 was +1 +2 +3. Okay, out of 5, +1 +2 +3, and last 2 +4 +4 only. And one more oxidizes I am telling you, that is the dinitrogen pentaoxide, N2O5. N2O5. Here it is called nitrogen 5 oxide. Oxidation state is +5. Oxidation state is +5. That's why it is called nitrogen 5th oxide. Correct? And how will you get this? How will you get N2O5? Then that you will get by use of 2 reagent. What are that 2 reagent? Then first reagent is nitric acid, and second reagent is P4O10, dimer of P2O5. Phosphorus pentaoxide is there, P2O5. Its dimer is P4O10. P4O10. Then here to get nitrogen pentaoxide, dinitrogen pentaoxide, here you are requiring what? P4O10, dimer of P2O5, phosphorus pentaoxide. Then balanced equation I am telling you, that 4HNO3, 4 molecules of HNO3 and 1 molecule of P4O10, it gives 2 products. What are that? Then you will get HPO3, phosphoric acid. Okay, or phosphorus acid also you can tell, H3PO4, that is a phosphoric acid, but it is of different type, I will tell you. Then now we will get 2 products, HPO3 and N2O5. 2 products you will get. What are the 2 products? Then HPO3 and other product is N2O5. Okay. Then balanced equation you can understand like this: 4HNO3 plus P4O10 is equal to 4HPO3 plus 2N2O5. Okay. And what is its property? Then this is again solid. This is again solid, colorless solid, and its character is acidic character. Then here 3 solids you got. First blue solid, that is the N2O3, and last 2 is again solid only. Colorless, both are colorless solid, means N2O4 and N2O5 both are colorless solid. Then N2O4 is solid and liquid, both can be there, but N2O5 is only solid, not liquid. And acidic nature, then all you can say out of 6, all 4, last 4 are acidic. Last 4 means N2O3, NO2, N2O4, N2O5, all are acidic. And this +1 and +2 means N2 and NO, both are neutral, no basic. Okay, no basic. Because question is asked acidic, basic, neutral like this. Then now understood, I think so, that out of 6, first and second is neutral, and last 4 are acidic. Okay, and solid, which are the solid? Then heavy, always heavy molecule will be solid, always. This is a rule. Then N2O3, N2O3 is heavy, that's why it is solid, blue solid. And after that you can say N2O4, dimer, again it will be solid because it is molecular mass is more. Then it is also colorless solid, and it can be converted liquid also. And N2O5, again it is a high molecule, N2O5, that's why it is again solid, but it is colorless. Okay, then here you have seen that except two all are colorless. That is the N2O3, that is the blue color, that is a colorful. Another colorful is NO2, brown gas. Other are colorless. Okay, now I am going to discuss some important this about oxides only, but I will now focus about their structure of oxides. Okay, whatever I have discussed now, these things, oxidation state, preparation and properties I have discussed. Okay, important properties and preparation I have discussed. Now I will tell about their structure. Okay, structure is also very important in written examination. This is asked, or objective type also can be asked. They will give possible option. Suppose 4 options they are given, then 4 structure they will give. You have to answer correct structure. Correct? Then in both examination, written, subjective as well as objective, in both examination it is asked. Okay, and then first I will tell about the N2O. Okay, N2O, that structure of N2O. Then now how will you understand this? Then I will tell the these things, bond wise you can understand. Then N2O, then NN, bond is there. All bond actually are in the one line. First 2 nitrogen is there, but between the 2 nitrogen double bond is there, and after that 1 oxygen is there. Then this is also double bond, N and O, double bond is there. Then in N2O, NN is double bond, and N and O also double bond. Okay, and first nitrogen, total 3 atom is there, NNO. Then first N has 2 lone pair. 2 lone pair means 4 electrons are there. Okay, 4 electrons means 2 pair. And oxygen also have 2 lone pair. Both nitrogen and oxygen have 2 lone pair. Okay, this is the first structure. Then this structure can also be written. This structure also can be written. That is the second structure. How will you write N2? I am telling you. That is the NN, triple bond, and with N 1 oxygen is joined. Means that time you have seen in first structure that total you can say this N and N double bond was there, N and O also double bond was there. But now N became triple bond, then obviously N and O will become single bond. Correct? N triple bond and NO single bond. Then it will affect the lone pair of electron. Then now N, first N, they will have only 1 pair of electron, means 2 electron, because one pair of electron is used up in making triple bond. And here oxygen, it was having a 2 pair. In the first structure it was having 2 pair of electron. Now when it became single bond, then now it has 3 pair of electron, lone pair of electron, 3 pair, total 6 electrons. Then you can write in both way. Okay, means from the first structure you can get second structure, from the second you can get the first structure. Arrow sign you can write in both way. Okay, that from reactant to product, one arrow sign, and from product to reactant again arrow sign. Both side arrow sign you can write, because from the first you are getting second structure, the second you are getting first structure. Then now actually what about this bond, that is also called bond parameters. I have discussed now that this resonance structure I told now. Two structure was there, both are interconvertible. First was converting to second was first, that is called resonance structures. Then now I am telling about this bond parameters. What are about the bond length? Okay, then N and N, that bond will be 113 picometer, PM 113 NN bond. And what about the N and O bond? Then that will be 119 picometer. Means NO bond is longer than NN bond. Okay, and it is a linear structure. Question is asked about the N2O. What type of structure it has? This is a linear structure. Now come about the NO, nitric oxide. NO. Then one N and one O, only 2 atoms are there. Then N and O, double bond is there. N and O, between N and O, double bond is there. Then already you know that octet must be completed. Means total 8 electrons should be there on both atoms. Always you think like that every atom should get 8 electron. Okay, even a sharing is there, then in that also sharing electrons you can count in both. With both atoms you can count sharing atoms. Suppose double bond is there, then 4 electrons will be counted for both, for nitrogen also, oxygen also. Correct? Anywhere you can, in a general way I am talking about. Then here you have to think like that. Then total electrons should be 8 for both atoms. Sometimes you will find that it is not getting complete 8. It happens many times, particularly in a nitrite. If you see, then you will find that this is not getting complete 8. Then that condition will be different. Only here I am telling you, already once I told you in the beginning, in that previous classes, when I discussed up to 13 these things, 12, 13, I discussed that time, that bond can, we know that bond can be made by single electron also, by single electrons. Then how? Then because electron will be always moving, then it will 50% time it will spend for both atoms. That is a boron example I have at that time I have given. In boron is the best example. In boron, that their single electron bond is there. then this happened because of electrons are always electrons are in always electrons are moving, and that 50% time they are spending with both atoms, hence they will make a bond. Okay, already I have discussed the diboron already I have discussed that is a due to that it became banana structure. Question it is for advanced level and for higher level this question is asked. Then then due to this you can say single, they can form from one electron single bond also. That's why like that way it will make up 8 electrons where it is lagging behind. Okay, then some examples are there where you will not get full 8, but you should not be afraid, because that you can't see, because it is moving both sides. How will you write? But you have to take a concept like that. Then now I am talking about NO, nitric oxide. Then two atoms are there, N and O. Then N and O, double bond is there. Then now to complete the octet, both atoms will have electrons, remaining electrons. Then you know that in one electron, in general, in one electron means one bond means 2 electrons. Then 2 bond means 4 electrons. Then with nitrogen 4 electron you can count because it is common for both N and O. Then now how much it will remain? 4 already you have told. Then now here you will see it should be 4. On a nitrogen it should be 4, but now actually it is a 3, only 7. 4 plus 3, 7. Here also you can see a single electron, like that concept will come here. Here again N has 7 electron only. 4 electron that is involved in bond formation, 2 bond is there, 4 electron plus 3 is on nitrogen. Then nitrogen got only 7. And oxygen now we are getting total, if you count that common 4 electrons, and here it is 5 electron. Oxygen has 5 electron, 2 pair plus 1 electron, 5 electron. Then now see here, there nitrogen is lagging 1 electron and here oxygen has extra. Okay. Oxygen has extra electron and nitrogen is lagging behind 1 electron. Then anyhow, again same type of concept will be there, single bond electron, but here anyhow 2 electrons are there. Nitrogen is lagging 1 electron, oxygen is having 1 extra electron. Correct? Then in N and O, oxygen is more electronegative. Sorry, fluorine, you know that highest in whole periodic table, fluorine is the highest electronegative, and second position is of oxygen, third is of nitrogen. Okay, after that it will come chlorine, bromine, iodine. Then that's why oxygen is having 1 more electron. It attracted 1 electron towards itself because it is more electronegative than nitrogen, and nitrogen is lagging behind. Then anyhow that it is all are getting, if you conclude all, then you are getting total 8 and 8, 16 electrons are there. 4 in the middle, 4 electrons in bond, and now 3 electrons on nitrogen. Then 4 plus 3, 7, and now this side how much there for oxygen? Then now 4 plus 5, 9. 4 plus 5, 9. And 9 plus 7, 16. Correct? 4 is common in both, but you count separately both. Then 4 plus 3, 7 on nitrogen, and 4 plus 5, 11. 4 plus 5, 9. Okay, 4 plus 5, 9. That is an oxygen, one extra. And then 9 plus 7, 16. Then now 8 plus 8 they require. Now total 16 is there, but position is different. Oxygen attracted one extra electron. Then now this structure, because it is a resonance structure, then now you can write again in a reverse way. Now nitrogen will have one electron and oxygen will have one electron less. What is in the first structure? That one electron difference was there. Now it will be reverse. Now electron will have 4 electron. It was having 3 electron. Now it is 4 electron. Then now oxygen side 1 electron will be less. Only 4 electron will be there. This is the resonance structure of NO, nitric oxide. Means from a structure 1 you can get a structure 2. From the structure 2 we will get 1. Hence both structures are called resonance structures. Now what is these things? Structure that is actually linear. This is also linear. Okay, in one line they have straight line is there, linear. And N and O bond is there. How much? Bond length between N and O in NO. Then this is 115 picometer, 115 picometer. Now third, I am talking about the N2O, third oxides. Third oxide N2, no, third is N2O3. Third N2O3. Then now see 2 atom of nitrogen and 3 atom of oxygens are there. Then NN, that is a single bond. After that 3 oxygen is there. Then in one nitrogen 2 oxygen is attached, and in other nitrogen 1 oxygen is attached. Then out of 3 oxygen, 2 oxygen is joined by double bond with N. 2 oxygen out of 3, 2 oxygen this joined by nitrogen with double bond, and 1 oxygen by single bond. Then now again you have to maintain the octet. If you will count, it will be completed. In first you can count first N and O bond. Total 3 bond is there. Then 2 oxygen got double bond, and 1 single bond. Then first oxygen double bond, it means double bond means 4 electron, and now 2 pair of electron is there. Then now octet is complete. 4 plus 4, 8. Now only in the same nitrogen 1 more oxygen is attached with single bond. With the same nitrogen, N is making double bond with 1 oxygen, and with other oxygen single bond. Then now you count it, total number of electron. Then single bond means 2 electron, and oxygen have now 3 lone pair of electron. On oxygen 3 lone pair of electron. 3 lone pair of electron. Then 6 plus 2, 8 electron. And now second nitrogen, you again double bond is there with oxygen. Then again same way, double bond is there means 4 electron, and oxygen has 2 lone pair of electron means 4 plus 4, 8. Now count for the nitrogen. Then now you know that nitrogen is making double bond with 1 oxygen. Then now that is the 4 electron, and with other 1 oxygen 2 electron. Then 4 plus 2, 6 electron, and with other nitrogen single bond they are making, both nitrogen. then there 2, then 8 electrons. Like that way, you can also understand these things. Nitrogen of second nitrogen. Then second nitrogen again, N and O double bond is there. Then 4 electron is involved. 4 electron and 2 electron is involved in N bond. 4 plus 2, 6, and 1 lone pair of electron is there on a nitrogen. Second nitrogen, 1 lone pair. Now it became 8. Then now this is the first structure. Second structure, same way you can write, because it is the isomer, these things resonance. Then in first nitrogen it was 2 oxygen was joined. Now in second structure, what you will write? What you will write? That here where double bond was there you can, oxygen and nitrogen double bond was there. In one nitrogen was joined with 2 oxygen. One was having double bond, other was having single bond. Then now in second structure, double bond will become single bond and single bond will become double bond. All things will be the same. Correct? N and O in with first nitrogen double bond was there, and with other oxygen single bond was there. Now just it will reverse. Now means in second structure double bond will become single bond and single bond will become double bond. All things will be the same. Then this is the resonance structures. Both structures are called resonance. Okay. Then what about their bond and angle? Because this is not the linear. It has some angle. Angle is there. It is not in one plane. Angle is there. No, this is actually planar. This is the planar, but between the 2 atoms they are making angle. As for example, first nitrogen was joined with 2 oxygen. Then between the 2 oxygen, O and O, what is the angle? Then that angle is 105 degree. Okay, means here I am telling you the 2 angles. Here you have to 2 not 3 angles should know. First that if you will count O N bond, if you will count oxygen, nitrogen is there, na? Then 3 atoms are there, oxygen, nitrogen, and again nitrogen bond was there. Then it is making 105 angle, and bond length for this is 114 picometer. If will come to the other nitrogen, then there it is joined with 2 oxygen, nitrogen in the middle, O and O. Then here angle is more. Angle is 130 degrees. And third angle, where is third angle? Then now third angle is making with NNO. Okay. Then its angle is 117. Okay. 117. This is the angle. And what is this NO bond in this case? Then NO bond is 121 picometer. Now you can ask the question, why bond length is differing? Then bond length differs because I already told you that with first nitrogen and oxygen bond was there, then there it was 114. But here in the second nitrogen, oxygen is joined, single bond I am talking about, then their structure is different. Then bond length depends upon the what type of bond is there. If double bond is there, then it is stronger. stronger, then they will attract, means other molecules will be closer and double bond, because bond is strong. Then that's why bond length will be less. Bond length will be less because they are closer in comparison to the single bond. And one more reason is there. If you can say if you can say angle is more, angle is sometimes angle will be less, then there a strain will be there, a strain will be there. And if angle is more, then less strain, and that time also it affects the bond length. It affects the bond length because now it will go far. It will go far. Then that you can say angle also affect this bond length. Okay. Then I have told about the N2O. Now I am telling about the NO2. NO2. Then NO2. Now one nitrogen and two oxygen is there. Nitrogen dioxide I am talking about. Then here again both oxygen is attached with nitrogen with some angle. Okay. Then one oxygen is making double bond and other oxygen is making single bond. Then again you can count the electron, same way we will get. Double bond means 4 electron and 2 pair electron is an oxygen. Then 4 plus 4, 8 electron. And second NO bond, N and O, then single bond is there, and single bond means 2 electron and 3 lone pair is there on that oxygen. Then 6 plus 2, 8 electron. And nitrogen, if you will count nitrogen, then you will find now double bond means 4 and again single bond means 2, then 4 plus 2, 6. 4 plus 2, 6. Then now 2 electron is there on nitrogen. Then 4 plus 2 plus 2, 8 electron is there. Then now that way it is electron octet is, means every atom has a octet, got octet, 8 electrons. And now there you can say resonance structure, second structure, if you will see, then again where double bond was there will be single bond, and where single bond was there it will be double bond. Okay, that only difference. Double bond became single bond and all things will be the same. Okay, then this is also called resonance structure of NO2. NO2. Okay. Then this I have told you about the structure. Now I am telling about, but here you should also, one thing you understand, nitrogen has in their outermost only 5 electron, correct? And so what will happen, actually they should get octet, but because they have only 5 electron, then wherever this structure you will see related to nitrogen, you will find that there 1 electron it will lag. It should be actually 2, but it will be mentioned as 1 only in molecule, because now they become molecule, then it should be 8, but it is not actually 8 for nitrogen, it will be 7 only. Then you can show actually only 1 electron. Okay, in normal cases it will be octet in normal cases, but actual fact in other atoms except nitrogen or particularly nitrogen or where this type of case is there, 1 electron will be there. That's why they are forming a dimer. Already I told you dimer. Then here in N2O, one electron is only there. Okay, one electron on N means N have only 7 electron. Okay, then here I told you about this, and then it is N2O. N2O I told you. Then now second structure where double bond was there, that becomes single bond, and where single bond was there, that becomes double bond. Both are resonance structure. And what is the angle and bond length? Then just like these things, for N2O3 I told you it is a planar. Planar structure means one plane, just like a paper. One sheet is there, that is in one plane. If it will go up, then it will be called angular. Okay, angular. Then this NO2 is called angular. Okay, angle will be there. Then here between ONO bond, ONO, N is the middle, that bond is 134 degree, and bond length, N and O bond length is 120 picometer, 120. Okay, like that way. Now N2O4, that is a dimer. Then now because now here N2O4 means 4 oxygen is there and 2 nitrogen there. Then with each nitrogen 2 oxygen is attached with each nitrogen. Same way, one oxygen making double bond, other is making single bond, but oxygen will maintain their octet. Then N and O, double bond means 4 electron and 2 pair of electron is there on oxygen. Then 4 plus 4, 8. For this oxygen 8. And NO bond, single bond. Then here again 2 electron is involved in single bond and 3 pair is there on oxygen. Then 3 pair means 6 electron plus 2, 8 electrons. And on a nitrogen, now you can see that here, because that lone pair of electron, when it was only one N, 1 electron was there, but now that is used in making the bond with sharing the electron. Then now nitrogen also got 8. In this case it is 8. Then now double bond means 4 electron and NO single bond 2 electron, then 4 plus 2, 6 electron, and N 2 electron, 8. Then same way with second nitrogen, they have two oxygen, one is double bond, other is a single bond, same way. Then now resonance, second structure, how can you write? Then it is very easy to write the second structure. That now these things in the first structure, both NO double bond was there, both down it was there. On both nitrogen, oxygen bar joined with double bond. On both nitrogen down. But now in second structure, first nitrogen which was down, oxygen nitrogen double bond which was down, that will go up, and up will come down, means the second nitrogen there will be no change, it is as it is. In the first structure, both oxygen was having double bond with N. But now in second structure, one nitrogen means second nitrogen will be the same, only first nitrogen their structure will interchange, which was double single bond, that will come double, and which was double, that will come single. Correct? This is also resonance structure. Now what is its these things? I am talking about, that is I told about resonance structure, but what is the parameters? Then here now you can see major angle I am talking about ONO bound in N2O4. ONO, this bond is 135 degree. Okay, and what is the NN bond? NN bond, then 175 picometer. And other nitrogen is there, second nitrogen, that is also angle they are making ONO, then their angle is 121 picometer. Okay, and this is also planar structure. Only NO2 was having angular structure, NO2. Okay, but now this N2O4 is planar structure, and last structure is N2O5. That means 2 nitrogen and 5 oxygens are there. Then it's a structure you will think that it will be difficult, but easily you can understand. Okay, without seeing the diagram you can understand. Here what will happen, that 5 oxygens are there. Then NO2, that structure you know. NO2, that structure you know. But here what is the different N2O5, that this NO2 structure you know that ONO bond is there. ONO. Okay, that angle will be the same. Then now I am talking this NO2. Both NO2 left side, NO2 right side, both are joined with oxygen in the middle. Through the oxygen, both nitrogens are joining. Okay, means NO2 and both NO2, on left side, other right side, both are joining oxygen. Then now it became 5 oxygen, NO2. In NO2, 2 oxygen, and other NO2, again 2 oxygen, and 4, and fifth one is between the 2 nitrogen. Means both NO2 is joined by middle oxygen. And if you will count this electron, then everywhere you will find 8 electron in the same concept. Okay, same concept, you will get complete you will get 8 electron. Okay, where the structure is very clear, because NO double bond, then 4 electron, and 4 electron is an oxygen, 8 electron. Nitrogen will count, then NO 4 electron, plus both side NO single bond is there, then 4 plus 4, 8 electron. Okay, and middle oxygen has 2 lone pair of electron, then 4 electron, and with this middle oxygen NO and 2 electron. Then now 4 plus 2 plus 2, 8 electron. Same way is with second electron. Now second structure of N2O5, because it is also resonance structure. Then here all things are same, only what is the different? Only different with first nitrogen. With first nitrogen 2 oxygen was joined, then double bond, which was the upside double bond NO, that will come down, and down will go up. Means double bond became single bond, single became double bond with first nitrogen. Second nitrogen is same, and oxygen already in the middle, hence this is the second structure. Then both are resonance. Resonance means always almost same, minor change will be there, and due to that change there will be energy change, because mild little change in structure is there, then it will involve just some energy difference will come in both. If we measure the energy difference in both some energy difference will be there in both structure. That energy is called resonance energy, and that energy, due to that resonance energy, that structure will become strong. Resonance structure will be strong. Okay, already I have discussed. Then this is also planar structure, and here if you will if you want to know angle between middle oxygen NON, what is the angle? Then that angle is 112 degrees centigrade. 180 is the straight line, 180 degree means a straight line, but here is a 112. It means you can understand that is not a straight line. Okay, some angle 112 degree is there. And what is actually bond length? Then bond length for this single bond NO, that is 151 picometer, and one side 151, and other side NO, other nitrogen NO bond length is more, 115 picometer, means a little weak than first NO single bond. Okay, both are single bond now, both nitrogen upside single bond, but due to difference in angle, their bond length changed. Then with second nitrogen ONO, that bond is 134 degrees centigrade. Then this I have told you about all this structure of all oxides of nitrogen from +1 to +5. All details I have discussed, and many question is asked. Okay, and see, you should know here out of this all structure, only one structure, first was the linear, second was planar, third was angular. Angular means NO2. Remember, that is the angular, and this second and fourth both are planar. Before angular, that is the second, and after the angular one more, that is the fourth one, means second and fourth, that is the planar, and fifth is also planar. Then total three planars are there, and one linear and one angular. Okay, then this I have told about the structure of oxides of nitrogen. Okay, next class I will continue nitric acid. Thank you.